Dear students, so in this session I'm going to explain about second experiment called as amplitude shift keying generation and detection. Dear students, amplitude shift keying, frequency shift keying, phase shift keying or digital modulation techniques. Okay, digital modulation techniques. You studied amplitude modulation, frequency modulation and phase modulation in the previous semester in the analog communication lab, or in the fourth semester I hope you studied analog communication experiments. See, analog modulation techniques are amplitude modulation, frequency modulation and phase modulation. But in digital communication system, you have the digital modulation techniques. So the amplitude AM, FM and PM are replaced by ASK, FSK and BPSK or PSK. See here, what is the difference between this analog modulation techniques and digital modulation techniques? In the analog modulation techniques, the characteristics of the carrier wave or carrier signal which is modulating with respect to message signals are analog in nature in case of analog modulation technique. But in case of the digital modulation technique, the characteristics of the carrier which is varying with respect to the message signal is digital in nature. Okay, hence it is called digital modulation technique. So in ASK, the amplitude of the carrier which is shifting between the binary ones and zeros, or amplitude of the carrier signal which is switching or keying between the binary ones and zeros, that is called as an amplitude shift keying. So in this experiment we are going to generate ASK and as well as to recover original message signals back from the what is modulated signal. What are the operators required? So we need one transistor is required, one op amp is required, one diode is required, and resistors as per the design, and potentiometer of 10 kilo ohms is required. So modulation circuit and demodulation circuit is shown in the figure. The first one is the modulation circuit. I want to explain the operation of the modulation circuit. Dear students, kindly concentrate on this. So the modulation circuit which contains one transistor and resistors, and also it requires one carrier signal, one message signal, and one CRO is required to measure the output. See, you are observing message signal is binary signal or digital signal. So it is high or low or binary ones and zeros. Whenever the message signal is high, so you have to select a square waveform or the pulse for the message signal. So when the message is high, means what? When the message is high means it is binary 1. When the message is binary 1, then the transistor is turned on. When the transistor is turned on, the amplitude of the carrier signal which is transmitting. When the message is 0, the transistor is turned off. By that time, a very negligible amplitude of the carrier is transmitting, or ideally speaking, so no amplitude is transmitting when the binary is 0. Practically speaking, very negligible amplitude of the carrier signal is transmitting when binary is 0. Okay, this is about the modulation circuit and demodulation circuit. Dear students, the modulated output is given as input to the demodulation circuit. Your demodulation circuit which consisting of the envelope detector and the comparator circuit. So your envelope detector which consisting of an half rectifier with the capacitor filter which produces the DC signal. That DC is comparing with the reference signal which is applied at the pin number 3 of the op amp. Then if the obtained DC voltage which is greater than reference voltage, then high signal is detected. Otherwise the low signal is detected at the output of the demodulator circuit. So demodulation is a process of removing the carrier signal, and also it is a process of recovering the original signal back from the modulated signal. Let us see the waveform for this ASK modulation and demodulation. So before that, let us see the procedure. What is the procedure for this ASK modulation and demodulation experiment? Connections are made as per the circuit diagram, and you have to apply the square wave modulating signal of 500 Hz of 10 volts peak to peak. So always the message signal frequency is less than the carrier signal frequency. So why the capacity of the carrier signal is more than capacity of the message signal means, so carrier has to carry the message signals during the modulation. So apply a sine wave carrier signal of 50 Hz 50 kilohertz and 5 volts peak to peak as an amplitude. And observe the ASK waveform at point A. Demodulate ASK signal using the envelope detector, as I told you already, to find the minimum frequency of the carrier signal for proper detection. And after step 5, start reducing the frequency sine wave. This is very simple. Once you connect that modulated output as input to the demodulation circuit, and slightly vary the potentiometer, and set the reference voltage as 1.1 volts or 0.2 volts, definitely output is obtained. So the output is little distortion, but compared to analog modulation technique, the distortion in the digital modulation technique is negligible and very less. Let us see the waveform for this ASK generation detection. The first one is, what is that message signal. Message signal is binary in nature, ones, zeros, 1 0 1 0. See what is the message signal here, 1 0 1 0 1 0. This is the message signal. Carrier signal is continuous in nature. See what happens when the message is high, the transistor is turned on, and what is that the amplitude of the carrier is transmitting. Okay, so when the message is low, no carrier, very negligible amplitude of the carrier is transmitting. Okay, that is close to zero, and again when the message is high, the amplitude of the carrier is transmitting. Okay, this modulation technique is also called as on-off keying technique. You are observing when the message is high, it is transmitting, so that it is on. When the message is off, it is not transmitting, means it is off. Hence ASK is also called as on-off keying technique. And the demodulated output, original message is recovered, and little distortions also are getting practically. Okay, so this is the ideal output waveforms. That's all about your ASK generation and detection. So thank you for watching the